Hello, my dear JEE warriors. Welcome to the Kinetic Theory of Gases and Thermodynamics session with your Captain Shreyas, who is your experienced teacher for taking care of you in this final leg of your journey. And I hope you are all geared up because this is a very important chapter and this will easily fetch you at least 8 marks. I'm saying at least 8 marks. Okay? So get ready to get your 8 marks in your pocket with your Captain Shreyas, and please smash the like button, show your support, show your love as well. Thank you so much. Thank you so much for joining in today morning. Thank you so much, my dear warriors. I can see Advait, Black Ops, Anugna, Anudu, hello Praveen, hello Devri, hello Sanjay. Good morning, my dear students. And I hope you have checked out the free mock tests which are made available to you, right, based on the JEE pattern. It's a computer based test and you will get the analysis and the reports. So please make use of these tests, because every mock test that you give, you will learn something new. Don't think, sir, I have not studied the entire portion. What is the use of mock test? Remember, you have to face the exam anyways in 20 days. So better to know what is to come. So register for it. The link is down there in the description box. And also there will be an additional mock test on the channel which will be coming up on Sunday. So make sure you are subscribed on this channel. And yes, only when you like and only when you comment, then we will do more for you. If you don't like, you don't comment, we'll be like, okay, take care. Fine, you are not interested in JEE. Maybe you are interested in something else. So thank you so much. Yes, let's trend WP. All the warrior pandus in the whistle podu mode. Great. So let's begin. Starting off with thermal expansion, then I will go to kinetic theory of gases, then I will go to basically your thermodynamics and the processes. All right. So let's begin. When we talk about thermal expansion, see, any body, when you heat any body, you will see that that particular body will expand because the molecules need more energy. So the body basically, I would say, expands like this. There is expansion which happens. And similarly, if you have some body and you take away the heat from it, you cool it, or you take away the heat. Okay, so then you will see that the same body will contract. This is the phenomena of your thermal expansion. There are many things associated with thermal expansion, right from changing of areas, lengths, errors in the measurement, and even stresses and strains. All these concepts are involved over here. Now, when you talk about thermal expansion or thermal cooling, then either you can find how far are 2 points now, and then maybe these 2 points on the body are this much distance away. Now they are going this much distance away because you have heated and it has expanded. Or maybe you take an area, maybe a cross section or the surface or some other area or a patch, and then when you expand it, the area increases or it changes. And lastly, the volume. So when you basically heat it, the volume will increase, and that's why the density will decrease. Yes or no? Won't the density decrease, my dear students? Yep, the density will definitely decrease. So these kind of things we want to study over here. Starting off with, if you take a random body and it is now expanded like this. This is at T plus delta T temperature. This is the body at T temperature. And maybe there was a point here and there was some point here, and the separation between them is L naught. The separation between them is L naught. Now, Once you heat them, you will see these 2 points will go far away. Maybe this point comes over here, maybe this point goes over here, who knows. And this will be the new separation, which is basically L. This will be the new separation, which is basically L. So you can see the length has changed, and that delta L is given by L naught alpha delta T. L naught is nothing but your initial length. L naught is nothing but your initial separation or initial length. Alpha is nothing but called as your coefficient of linear expansion. Coefficient of linear expansion, and it completely depends on the material. It completely depends on the material. Keep this in mind. Delta T is your change in the temperature, of course. Delta T is of course your change in the temperature. Hello Sharon, hello Pooja, hello Vesari, hello Gayu, hello Gautam Raj, nice to see you all. Yes. Then if you write delta L as final length minus original length is equal to L naught alpha delta T, shifting L naught over there and taking it common, you will get it as 1 plus alpha delta T. This is also another way of looking at the same formula. This is one way of looking at it. This is another particular way of looking at the same formula. Is that okay? Cool. Now, similarly, if you take a body, this is at, let's say, if you take a body, let's say it is at temperature T, and then you heat it, and it becomes bigger in size at temperature T plus delta T. You take a small patch, it could be anywhere, maybe this patch over here, maybe that has an area A naught. Because you heated it, that area will expand. Maybe that area will become like this, maybe that area becomes like this. This is some additional area which has now come into play. Okay, so the total area now is A. So then you will see that the final change in the area will be, this is basically your change in the area. Remember that the change in the area will be original area, instead of alpha it is beta, and then you have delta T over here. This is your initial area. This is your initial area before expansion. Beta, just like before, instead of coefficient of linear, this is called as your coefficient of areal expansion. Areal expansion. It again depends on the material. Also note in mind that beta is 2 times of alpha. This is a very important result which you should know. Length is in 1 dimension, area is in 2 dimensions. So area is twice of the length. So that is the formula which relates alpha and beta. Yes. And just like before, you can also write the final area is the original area into 1 plus beta delta T. Just like you wrote final length is initial length 1 plus alpha delta T. Same way you can write it over here. So these are another 2 forms. It's exactly identical like length. Keep that in mind. Lastly, you have volume. So let's say you have some shape. This is at temperature T and it has some volume V0. But you heat it. So now the shape remains the same but the size increases. This is at T plus delta T. This is the final volume. Then the change in the volume, which is delta V, is given by original volume gamma into delta T. So what is V0? It is nothing but your initial volume. And gamma, just like before, instead of coefficient of areal expansion, this will be nothing but your coefficient of volume expansion. And can you guess how many times is gamma of alpha? Put it up in the chat box. Want to see whether you know this or can you guess this at least. I just told you beta is area and area is 2 dimensions, so it is 2 times of alpha. So my dear students, for volume, what do you think it should be? Very good. Yes, it is 3 times of alpha. Exactly. It is 3 times of alpha. Correct. And you can also write the final volume as initial volume 1 plus gamma delta T. That is also okay. So again, these are alternate formulas. Keep that in mind. These are your alternate formulas. Okay, looks very, very identical. Now it so happens that when the volume changes, obviously density will change. So you can get questions on density changes as well. So how to attempt those questions? How to attempt those density change questions? Observe this carefully. Let's say the original density is m by v naught. Now I want to find the final density. When I heat it, which is m by the new volume. So what you can do is put the final volume formula, which is nothing but, I just told you right over here, V is V naught 1 plus gamma delta T. So put 1 plus gamma delta T over here. What is m by V naught? M by V naught is nothing but rho naught, or the original density. It's nothing but your original density. So the new density is rho naught upon 1 plus gamma delta T. But remember one thing, these gamma, alpha, beta values are usually very small, and temperature change, that is also very, very small, like 10 degrees, 20 degrees, maximum how much? 100 degrees. We do not take 500-600 degrees Celsius change, because if that much change happens, maybe the object might even burn, might be turned into ashes, might just melt. So usually the temperature changes are decently small. Okay, no problem, Anushri. Good that you are relaxing via studies and not via some random reels or some random social media. Great. So when alpha is small and delta T is also small, it's not too much, then can I not say gamma delta T is much smaller than 1? So it looks like a binomial expansion now, but before making it look like a binomial expansion form, let's take it on the top. So rho will be rho naught 1 plus gamma delta T whole raised to -1. The whole thing raised to -1. Yep. Everybody? Cool. So now this is the binomial expansion form. So therefore rho will be equal to rho naught 1 plus nx. N is basically -1. X is basically gamma delta T. So therefore how much will rho be? It will be rho naught 1 minus gamma delta T. But remember, these are not exact. These are approximate formulas. These are your approximate formulas. Till here it was exact. This now became approximate. So this can be also used for finding the density change with temperature. Is that okay? So it's not like you have to by heart it, but at least this problem pattern you should know. It's just substituting the values. Then sometimes what happens, they combine it with rotational mechanics as well, like this. Say for example, there is thermal expansion plus rotation kind of questions. How do they combine them? So there will be something which is rotating and it is heated. There will be some body, let's say, there will be some body over here and it is right now rotating. And what you do is basically heat it. The moment you heat it, it will become slightly, bigger. And it might have a new omega. So it might have a different omega. So they might ask you whether the omega will increase or decrease. Well, one thing is for sure. If initial angular velocity was omega naught, the final angular velocity will be, come on my dear warriors, will it be more or will it be less? Think about it carefully and answer it. Yes, Viragayan, you can definitely watch it even if you are a NEET student, but we have a separate NEET channel, which is the Vedantu NEET English. Please watch it over there as well. Okay, but since you're already here, continue. It's okay. What do you think? Well, in such cases, remember one thing, it is the angular momentum which is conserved. Angular momentum is basically conserved. So what happens is, initial moment of inertia into omega, I omega, will be final I into final omega. Because it expanded, the moment of inertia increases. That's why the final omega decreases. This is because of expansion. This is because of thermal expansion. The moment of inertia will increase. That's why omega will decrease. Correct. These kind of questions do come. And when such questions come, how much is the change? Here is what you will do. Here is what you will do. You will just, find the new moment of inertia because of the thermal expansion. You'll just find the new moment of inertia because of the thermal expansion. And then you can find the new omega. Something like this. Something like this. I naught omega naught. I naught omega naught is nothing but the initial angular momentum. I will call it as L naught. This is equal to I into omega. Now I will be some m into the dimension of length will be there somewhere. Dimension of length will be there. I don't know, some radius, some length, something will be there, ml square, and some factor will be there. And this is omega. What is that factor? Like for rod it is 1/12. For disc it is half. For solid sphere it is 2/5. For hollow sphere it is 2/3. For ring it is 1. For solid cylinder it is half. For hollow cylinder it is 1. So that factor will be there. mr square by 2, ml square by 12, ml square by 3. Some m into square of the length into some number. Correct? That is how it looks like. Now if you rearrange it to find omega, omega will be nothing but, check this out, L naught by m f into L square. So therefore omega will be L naught m into f and L raised to -2. Now use the concept of errors. Now use the concept of errors, my dear warriors. If you see, L naught is a constant, m is a constant, f is a constant. So therefore del omega by omega, this is a constant, doesn't matter. Always take the mod value of -2. Always take the mod value of the powers into del L by L. Right? So this mod of -2 is 2. Change in the length by original length. Come on, my dear students. Change in the length by original length. Won't it be alpha delta t? Change in the length by original length. Won't it be alpha delta t? So that will directly come over here. That will basically directly come over here. So this is the relative change in the omega. This is your relative change in the omega kind of question. So if you want to find the change and you know the original, 2 times alpha delta t will be the relative change. A very important kind of question. Yes, everyone? How many of you loved this? Yep. So delta L by L will be just alpha delta t. Then you can also combine thermal expansion with solid mechanics. So you can also combine thermal expansion plus solid mechanics or mechanical properties of solid. How? Just observe. There is a rod over here and it is supported by 2 ends, rigid ends like this. Both the ends are rigid. The length is L. The Young's modulus of it is Y, and area of cross section is also given, and all of that. Okay, right now it is at some temperature T. Now what happens is you try to heat it, so it will try to expand, but it can't expand because of the rigid supports. So it tries to expand, but it can't because of the rigid support. So that's why there will be a compressive force. From the wall. And that compressive force by your unit area or the area of that section, that area of the section will give rise to a compressive stress, will give rise to a compressive stress inside the rod, which is called as the thermal stress, which is called as the thermal stress. The rod tries to expand, it tries to push the wall away, the wall will try to push it back inside, it will compress the rod, so that is the compressive stress. Is that right? Very good. So how much is that formula? That's the question. So for that, you just need to use the knowledge of solid mechanics and thermal expansion, nothing more. We know that Young's modulus is the stress, in this case it is the thermal stress divided by the strain. So the thermal stress will be equal to Young's modulus into the strain. Strain is the change in length by the original length, change in length by the original length. Now change in length by the original length is a standard formula. It is nothing but alpha delta t. It is nothing but alpha into delta t. That's all. So that is your thermal stress formula. It is Y alpha delta t. It is nothing but Y alpha delta t. Is that okay, my dear students? Very good. Keep this also in mind. Then you can also combine thermal physics plus oscillations as well. This chapter can be combined specifically with regards to this pendulum related questions. These are very, very common. There is a pendulum of certain length L given and it is right now having some time period of oscillation. So when you heat it, so then the length of the pendulum changes, so the time period will also change. This is the most common question which you can probably get. So we know that the time period of a simple pendulum, is 2 pi root L by G. This is your time period. This is your time period. Okay. So what I can do, I can just write it as 2 pi by root G, and this is length raised to half is basically your time period. So taking the error formula, which is delta t by t, which is the relative error. Delta t by t is the relative error. 2 pi by root G is a constant, don't bother. L's power is half, so into delta L by L. Now again, this is a common form. Delta L by L is alpha delta t, but be careful when you write this. Be careful when you write this. If you write this as alpha delta t, then one person might cancel this. Is this right or wrong? Is this right or wrong? Come on, my dear students. Is this right or wrong? This is wrong. Reason is, here this is time. This is time. Whereas here that delta T is temperature. So usually here in such cases you put delta theta. Here that delta theta stands for change in the temperature. This is the change in temperature, not time. Here that delta T stands for the change in the time period. Change in your time period. Those are two different things, don't get confused. So this kind of question might also come in your JEE Mains. This kind of question might also come in your JEE Mains. Yes, one is time, one is temperature. So usually temperature in many books is also written down as theta, so as to avoid the confusion. Then you might also get questions on something called as apparent expansion. Apparent expansion, these kind of questions you can get. So what happens in this apparent expansion kind of questions is that you might let's say have a beaker or a container, and in that there is some liquid, or some solid or whatever, and right now it is at some temperature T, but when you heat it, this container will expand. This container will expand. This is at temperature T plus delta T. Earlier this was at temperature T. So now you will see maybe the liquid might go up, might come down, depends. Maybe the liquid might even come down. Who knows? The liquid level might come down or it might even go up. It all depends on who will expand more. Whether the container expands more than the liquid or the liquid expands more than the container. Correct? Just imagine both the liquid and the container have the same gamma. So the container also expands as much as the liquid, so there will be no change only in the level. But if container expands more, liquid hardly expands, then the level will go down. So you might think, oh my god, is the liquid contracting? Actually it isn't. It's just a relative term. It's just a relative term. Similarly, if the liquid expands more than the container, then you will see the level of liquid going up. But the level by which it goes up is not the true level, because some amount is actually being absorbed by the expansion of the container. Because the container expanded, so it took in some expansion of the liquid. So here what you check is the relative expansion. This is the total relative expansion, is nothing but your expansion of the liquid minus minus the relative expansion of the container. So this is nothing but V naught into gamma L into delta T minus V naught into gamma C, V naught into gamma C into delta T. So V naught is common, gamma is inside. So V naught into gamma L minus gamma C, the whole thing into delta T. So this term over here, this is called as apparent coefficient of expansion. So here the gamma apparent will be gamma of the liquid minus gamma of the container. What you will be measuring will be apparent. This will be what is going to be measured. This is what you will be measuring. Understand that. This is what you will be measuring, because that is what is seen to you, apparent to you. But actually it will be gamma L, because you have to compensate for the expansion of the container as well. Correct. Then there was one type of question where, you know, there was a hole given and there was another a hole inside a disk basically. Okay, so this was a disk in which a hole was basically punched, something like this. And if the temperature is increased, what do you think will happen to the inner radius as well as the outer radius? Inner radius and also this radius, the small r and this capital R. What do you think will happen to this? Will both of them increase? Will only one of them increase? Or both will decrease? What do you think will happen? A lot of people think the outer radius will increase, capital R, and the inner radius will decrease. It will be pushed inside. But that's not true. It doesn't matter which 2 points you take on this particular disk. Even if you take this point and this point, even though it is not on the solid, but it's a part of the missing solid. It's a part of the missing solid. That's okay. You will see all the distances, including D. This D will increase. You will also see capital R will increase. You will also see small r will increase. In fact, you take any 2 points anywhere. Let's say I call this as L1. This length L1 will increase. Let's say I take 1 point here and another point here. Let's say I call it as X. Even that X will increase. Any 2 points, the distance will increase. It doesn't really matter. Yep. Achiever, I am taking V0 as the volume which was marked when the liquid was filled. So when the liquid is filled in this container, that V0 is the volume of the container only till here, not the entire volume of the container. So it's only the volume of the liquid which was here, and the volume of the container is also only till here, because this part only air is there. I'm not bothered. So maybe it is a 1 liter container, maybe only 200 ml is filled. So 200 ml is the volume which I'm considering. So that is what is marked on the container. That is what is the actual level of the liquid in the container. That is the amount of liquid in the container. So when that expands, I am bothered how much will that 200 ml expand for the container, for the liquid and apparent. Cool? I hope that is clear. Shall we do some questions? Shall we do some questions? Ready for it? Here comes the questions up on your screen. Two metal rods having same initial length, and you can see the ratio is 2:3, coefficient is in the ratio 3:4, when they are heated through same temperature difference, the ratio of the linear expansion is? The ratio of the linear expansion is in what ratio? Come on, two metallic rods A and B. Okay, so the ratio of their expansion delta 1 by delta L2 will be L1 by L2, alpha 1 by alpha 2, and delta T1 by delta T2. I think length ratio is already given as 2:3. Alpha ratio is given as 3:4. They are heated through the same temperature difference. So this is 1:1. 3 cancels, 2 4 becomes 1/2. So 1/2 is IIT Bombay. Just check this out. How many of you are writing IIT Bombay or B? Yes, you guys are correct. Very good. Proud of all of you. That is the correct answer. Temperature difference was same. Remember that. That's why it is 1:1. Moving on. Next question. A bimetallic strip is nothing but two metals attached together, one wanting to expand more than the other. And because one wanting to expand more than the other, you will say they cannot just expand straight, but they will end up bending. The reason why they bend is because when one of them bends, or basically when the bimetallic strip bends, then one of them is on the outer side, one of them is on the inner side. On the outer side, it is large length. On the inner side, there is less length, right? If you draw a big circle versus a small circle, the big circle has more perimeter than the smaller circle. So the one which is on the outside has more length as compared to the inner side. So if this is this kind of bimetallic strip, you can see the length on the outer side is more, whereas the length on the inner side is less. That means the alpha is less for this, and that means the alpha is more for this. So if it is clearly mentioned alpha A is less than alpha B, so alpha B will be this one and alpha A will be this one. So who is on the outer side? Obviously B is on the outer side. Just check this out. Yep, B is the correct answer. B is the correct answer. Very good. Is that okay, my dear students? Shall we go ahead, proceed ahead? Next question coming up on your screen now. Two rods of different materials having coefficients of expansions alpha 1 and alpha 2, Young's modulus y1 and y2 are fixed between two massive walls. The rods are heated such that they undergo the same increase in the temperature. There is no bending. Alpha ratio is given. Stress is developed are equal. What is y1 by y2? Question based on thermal stress. Question based on thermal stress. Thermal stress sigma 1 is equal to sigma 2. It's clearly mentioned. Thermal stress in the two are basically equal. And the formula for thermal stress is Y alpha delta T. Y alpha delta T. I just gave that to you. Y alpha delta T. Right? Now, I think the temperature change is the same. Temperature change is the same. So, delta T and delta T will cancel. So, the question is find Y1 by Y2. So, Y1 by Y2 will be alpha 2 by alpha 1. Alpha 1 by alpha 2 is 2:3. So, alpha 2 by alpha 1 is 3:2. Alpha 1 by alpha 2 is 2:3. So, the reverse will be 3:2. So, 3:2 is option C. That is the correct answer. Very good. Awesome. Shall we move ahead to the next question? Are you guys enjoying these questions? Yes. If so, do let me know in the chats or even in the comments. Okay, please leave a comment after the video ends as well. What should be the length of the steel and the copper so that the length of the steel is 5 centimeters more than the copper at any given temperature? Steel is 5 centimeters longer than the copper. So, longer than copper, longer than copper, longer than copper, no. Longer than copper, no. Do you see C and D option just got eliminated? How many of you saw that? C and D just got eliminated right now. You don't even have to think because clearly mentioned steel is longer. This is short than copper. This is short than copper. So either it will be this or either it will be this. Now if you notice option C, 28 point something, 18 point something, guys, this is 10 centimeter difference. So C option is also wrong. C option is also wrong, yes or no? So there is only one option, that means it must be A. So direct elimination, you don't even have to solve it. But this is what you will do in the exam if the options are like this. But what if the options are only cunning? What if the examiner, designed the options which are confusing, which you cannot eliminate? Then you have to solve. There is no other option. So let's try to solve it. Well, if you look at it, because the length difference should be same. Whatever change happens in the first rod should happen in the second rod, so that the distance between these two rods remains the same. That means delta L in copper should be delta L in steel. Delta L in steel. Delta L in copper will be L of copper, LCU, alpha of copper, which is 1.7 into 10 to the power minus 5 into delta T, which is equal to length of steel into alpha of steel, which is 1.1 into 10 to the power minus 5 into delta T. Delta T, 10 to the power minus 5 cancels. So I can just say length of steel is basically length of copper. 1.7 by 1.1 is 17 by 11. That's what it is. And we know length of steel minus length of copper is basically 5. This is what is given. So substitute this. This will be 17 times length of copper divided by 11 minus length of copper. This is equal to 5. Correct? Correct, everyone? Now 17 by 11 minus 1, that's basically 6 times length of copper divided by 11 is equal to 5. So length of copper will be 11 5s are 55 divided by 6. 55 divided by 6 should be 9.16. Check it out. So that will be, this one over here. That will be this number over here. 9.17. So you add 5 centimeters to it, you will get 14.17. Is that okay, my dear warriors? Understood? Straightforward. So we had to use two equations. One is the difference of the length is 5. Second is, since the difference is always constant, if copper increases by 5 centimeters or 2 centimeters or 1 centimeter, the other one also should increase by the same amount, so the differences are always the same. That's the concept used. Otherwise, elimination. The radius of a metallic sphere at room temperature T is R. Coefficient of expansion is alpha. Sphere is heated by delta T. New temperature is this much. The increase in the volume. I think it is direct question. The increase in the volume, delta V, is original volume into gamma into delta T. Original volume in terms of radius is 4 by 3 pi r cube. Gamma is 3 times of alpha, and 3 gets cancelled. So I am left with 4 pi r cube into alpha into delta T. 4 pi r cube into alpha into delta T is option D, right? Very nice. How many of you got it? Prasanna, some of them could be PYQs, some of them are non-PYQs, some of them are PYQ based, looking at the trends of what has been asked previously in the JEE Mains paper. Okay, so I am keeping it very high weightage, most probable pattern based on the previous analysis. Doesn't matter whether it is PYQ, it's a question, we have to just solve it, right? We'll not worry about all those things. How about this question coming up on your screen? It's an integer type of question, okay, in the nearest integer. So those last 5 questions which are there in your JEE Mains. Steel wire of length is hanging a mass of m. The wire is cooled now. The coefficient of expansion, modulus, everything is given. Wire's diameter, radius is also given. Length is much larger. Then the value of m is how much? See, the condition is mentioned over here. It regains its original length. Means what? See, this wire was there. Nothing was hanging. Let's say it was L. The moment you hang a mass, the length will increase. There will be some delta L increase because of the weight. Because of that weight, correct? So mg is there. So 100% there will be a tension. So because of that, there will be an increase. How much is that increase? Young's modulus is stress by strain. Stress is mg divided by your area, which is pi r square, whole thing divided by change in length upon original length. So if you just play around with this, you will see delta L is mg capital L divided by y pi r square. So that is the change in length which occurs because of, you know, elasticity. The string, that rope gets elongated. But now this is all happening at some temperature T. You cool it, cool by some delta T. So what will happen? The rope or that string or that wire will again contract, and again it will come back to that same length. It will now come back to the same length. So it has, you know, changed its length by delta L again. Correct? So that's the question now. So my dear students, that change in length will be L alpha delta T. Now this delta L and this delta L must be same so that it comes back to the original length. This is your original. Length. That's it. So now just equate both of them. I think that is the best thing that we can do. So L alpha delta T will be equal to mgl by pi r square into Young's modulus. So what is asked in the question is find the value of the mass. That means I need m. So m will be, first of all, LL will cancel. It will be equal to pi r square into y into alpha into delta T, the whole thing divided by G. Now substitute all the values, I think you will get the answer. Everything is given. Radius is given, that is given, this is given, everything is given. So you can substitute everything and you will get the answer. You know, the way I see it right now, I just realized pi is 3.14. Everything in this, including G. Take the radius. Radius is 1 millimeter. Modulus is 10 to the power 11. Change in the temperature 10. Everything is in powers of 10. Alpha is in powers of 10. Y is in powers of 10. Delta T is in powers of 10. Everything is in powers of 10. So won't the answer finally be 3.14 into some power of 10? So the closest integer which it will come out to be is 4 into 10 to the power something. But I think finally the answer comes out as a single integer. So most likely this will come out, that question mark most likely will be 1 only. So even without solving, I understood the answer is 4. I saved crucial 1 minute in the examination hall. I saved my crucial 1 minute. The question lengthiness is inversely proportional to difficulty. I agree with that. And even better are the calculations. Everything is in powers of 10. Look at it. That's the best part. Be it alpha, be it anything. So it saves me a lot of trouble. I know the nearest integer will be 4. Oh, by the way, the entire PDF will be available in the Telegram group. Make sure you join it. There are special quizzes which are being created for you in the Telegram as daily practice, as well as the link of Sunday's mock test will be shared only on the Telegram channel. So make sure you are a part of it. Okay. Now, Srija, if you want heat transfer and calorimetry, you can watch my old classes. That will be very, very helpful, right? So that is something which you should have a look at. Now, in kinetic theory of gases, I will add the notes later on after the lecture is over. I have not added it here right now, but there are some postulates which you must know. Like basic postulates are there, basic assumptions are there, based on which you derive all the formulas. So things like, you know, if you take a container, you will see that the molecules are basically, these are basically the molecules of a gas. This is nothing but your container. This is nothing but your container. And this KTG helps us, derive all the basic gas laws, the speed formulas, and so much more using Newton's laws and Newtonian mechanics. Basic kinematic equations and Newton's laws, all that is needed for getting all the basic gas law equations. These molecules are much, much smaller as compared to the container. So when I say the volume of the gas is 5 liters, the volume of the gas is 10 meter cube, does that also include the size of the molecules? The answer is even if you do, even if you don't, it doesn't matter because the size is so small. So whether you consider the empty space between the molecules or you consider the volumes of the molecules themselves, that's not going to matter. It's like saying, does Ambani have, $5 billion rupees or $5 billion, or does he have 5 billion and $1 or $1 less or $3 more? It doesn't matter. Those 3-4 things does not matter in front of billions. So the emptiness is much more than the size of the molecules. Not just that, these molecules, they move randomly. They move randomly and there is equal distribution in all the directions, whether it is up, down, left, right, front, back, doesn't matter. There is equal probability in all the directions. Keep that in mind. Also, the speeds are different. The speeds are very, very different. Some are very low speed, some are very high speed. So there is a range of speeds with which these molecules move. Not just that, these molecules do not interact with each other. So between those two molecules, there is no force. So between these two molecules, there is no force of interaction. There is no force of interaction between the molecules. This is an ideal gas. So that's the reason why the molecules will move in straight line paths. Until they collide with each other. They move in straight line paths until they collide with each other. If there were electric forces, then they would have gone in curved paths, but that electrical forces are very, very negligible. Not just that, you will see that when we discuss about the energy of the gas, although it is kinetic energy plus potential energy, this potential energy will be zero because no interaction force. So this will be basically a big fat zero. Hence, it will be approximately just the kinetic energy only because the potential energy will be zero of the gas molecules. Keep these things in mind. Next important thing which you should know regarding the gas laws or rather the kinetic theory of gases is that when these molecules hit the surface, of the container, when they hit the surface of the container, when they hit the surfaces or the walls of the container, when they hit, they exert impulses. They exert impulse due to change in the momentum. And that impulse due to the change in momentum per unit time gives rise to the force on the walls, or even the gas, and that force upon the area gives rise to the pressure of the gas. That force upon the area gives rise to pressure of this gas. Keep this in mind. Also remember, the duration of the collision is very, very small. The duration of the collision is very, very small, and the path taken between collisions is approximately a straight line. Now I have given you some of the main assumptions of KTG, which is something which you should remember, but there are some more which I'll be sharing it as notes. Where will you get the notes? Put it up in the chats. Where will you get the notes? Hello Krutik Pranav, thank you so much. Boss Gaming, can you watch my ray optics one shot which I had conducted before? That will be better. Yeah, and I will be doing ray optics PYQs. Can you do that? Can you do that? Right, my previous class which I was done before. If you want, I will just share the what do you say, link also. Yes, the black caps, you will get it on Telegram. So I will share the KTG postulates on Telegram in detail, right? I have explained you what it is, but in notes, if you want it in your book, I will share it on Telegram. Okay, let's have a look. Cooking gas containers are kept in a lorry. Oh, by the way, before this, yeah. When we talk about temperature of a gas, temperature of a gas, we generally think how hot or cold it is, but the way we define temperature in physics, temperature is a measure, it's a measure of the average kinetic energy of the molecules in the center of mass frame, meaning let's say one molecule is going here, 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 like this. You sit on their center of mass, you sit on their center of mass frame, and then you measure the speeds, and then calculate their kinetic energy, K1, K2, K3, like that till Kn, and take their average, that means divided by n. So you will get the average kinetic energy, all these kinetic energies are measured from the center of mass frame. Then you will see the temperature is some function of this average kinetic energy. Temperature is some function of this average kinetic energy. So it so happens that if the speeds increase, let's say if the speeds increase, even the average kinetic energy increases, and once the average kinetic energy increases, you will see the temperature also goes up. So temperature is nothing but how many molecules are vibrating, and are they vibrating more, are they traveling more, are they having more speeds, are they rotating more. So if they have more kinetic energies, then it has more temperature. So more temperature just means, it has more kinetic energies, they have more vibrations, more speeds, and all of that. Yes, oxytocin, you can definitely watch it. Correct. So keep all these things in mind with regards to temperature. So we have discussed pressure, we have also discussed temperature, we have discussed volume also in this particular slide, and that's when you get, using these assumptions, you get the ideal gas equation. From this, which is nothing but PV is equal to nRT, or you can also write PM is equal to rho RT. One and the same thing, is just writing it in different forms. Please remember, this temperature has to be absolute temperature, in, preferably we put it in Kelvin, right? We put it in Kelvin. This R is your gas constant. R, which is 8.3. Usually we use it in SI units, especially in physics, unless you are using it in chemistry like 0.0821 liter per atm or 2 calories per mole and all of that. This is your molecular mass. And obviously this is your density. Keep this in mind. This is your number of moles. Now this number of moles can also be written down as number of molecules upon Avogadro number. This is nothing but 6 into 10 to the power 23. This is the number of molecules, right? These are again important formulas. Also, you should know about M and the relation of M with, Avogadro number or mass of a molecule and all those things. Like, for example, small m, which is the mass of a molecule, is that molecular weight upon the Avogadro number. Molecular weight upon the Avogadro number. Very, very important formula again. Here, this is your capital M, which is molecular mass. This is mass of a molecule. Mass of a molecule. Mass of a molecule. This is molar mass. Molar mass is always per mole. So 6×10 to the power 23 molecules have these many grams or kgs of mass. So a molecule will have these many grams divided by the number of molecules which are there in 1 mole. That is what it is, right? So these things you should know. How many of you know all these things? How many of you know all these things? If you know all these things, very good. Proud of all of you. Proud of all of you. Okay, let's have a look at certain questions coming up on KTG. Cooking gas containers are kept in lorry which are moving with uniform speed. So there is some gas and it is kept in some lorry over here. And that lorry is moving with some uniform speed. Remember, the gas is here. So what do you think will happen because the lorry is moving? What do you think will happen just because the lorry is moving? Come on, my dear warriors. Think quickly and let me know. Will the temperature of the gas increase, decrease, remain same, or decrease for some while increase for others? If you answer this, I'll be really, really super duper proud of all of you. If you answer this, I'll be really, really super duper proud of all of you. Come on. What is the answer? Increase, decrease, remain same. Many of you might be thinking, sir, the speeds are increasing, so hence the kinetic energy will increase, hence the temperature will increase. But that is not the correct answer. In fact, many of you have got it right. Proud of you. Yes, you made me proud. Answer is Captain Shreyas. Very good. Because if you sit in the center of mass frame, then you will not see only any change. The center of mass is also moving with same speed, so there is no change at all. Else, you would say, so right now that room temperature is 27 degrees Celsius, but if I sit outside the earth, because the earth is also moving, then it has more kinetic energy. That means the gas has more temperature. What nonsense. It can't happen like that. Temperature is not like a relative thing. From this frame it is different, from that frame it is different. It is the same thing. So please remember that it is always measured from center of mass frame. Now a real gas has interaction between the molecules. A real gas does not obey the ideal gas equation. There are certain conditions under which a real gas comes very close to an ideal gas behavior. When is that? Is it at low pressure or high pressure? Is it at high temperature or low temperature? Think about it. Come on, my dear students. Which kind of pressure is it? See, think about it. The molecules should not interact much. When the molecules come very close, then the empty space will go off. So then the size of the molecules will matter. So when the molecules are very far, the emptiness is more, the size of the molecules won't matter. When they come close, then the emptiness will be less. Size of the molecules will become comparable with the emptiness between them. So the assumption of the volume of the container is the volume of the empty space will go wrong. Second problem, the molecules will start interacting. There will not be in the straight line path, there will be potential energies and so many other effects. So that's why you want them to be far away as possible, and that will happen at low pressure and high temperature. When the pressure is low, that means the molecules are far. When the temperature is high, the molecules have so much energy that they shoot out with large speeds. That's the reason why it is B, IIT Bombay. Correcto. Very good. Moving on. Next question coming up on your screen is here. There is a cylinder, you can see, it contains some ideal gas in this part. There is a piston and there is a mass attached to it. The mass can go up and down with the piston without any friction as shown. If you increase the temperature of the gas, who will change? Pressure will change, volume will change, temperature will change. Come on, think about it. If the temperature though will change because it is increased. So think about the molecules of the gas over here. Over here, it is mentioned that their temperature is increased. If you observe carefully, this mass from the top will apply a force which is equal to mg. That will give rise to a pressure which is mg divided by area. Is mass changing? No. Is g changing? No. Is area changing? No. So is pressure changing? No. Even if it goes up, even if it comes down, doesn't matter. The pressure is going to be a constant, and because pressure is going to be a constant and PV is equal to nRT is the gas equation. So think about it, my dear students. If the temperature increases, volume should increase, pressure will not change. That's it. So what is the answer? Volume will change but not the pressure. Volume will change but not the pressure. What a brilliant question, right? These are based on your KTG ideal gas equations. Let's proceed further to the next part. Speeds of the gas molecules. Ready? Speeds of the gas molecules. Then we are going to go towards energy. All right. I hope the speed is fine. I hope you are learning a lot, and I hope this theory and concept and your problem combination works the best for you in this flash series. Okay. All right. So all the warrior Pandus are ready? Cool. And wake up all your friends, yeah? I think they are sleeping. They think that classes are only in the evening. Morning class means okay, we'll watch it aram se. I don't know how many more days will you take to start studying in the morning. Exam is around the corner. Everybody should be awake in the morning itself. And what time do you usually wake up? Is it 6 o'clock, 5 o'clock, 7 o'clock, 4 o'clock, 10 o'clock? Yeah. Let's go. I hope all of you at least wake up in the morning, at least in the last few days. For the next few months, at least wake up in the morning and finish off all your studies. Don't stay awake late night. It will cause undesirable effects on your body. Okay? Yeah. Because anyways, if you're staying up at night, might as well stay up in the morning and sleep early. It's one and the same thing. It's just a matter of one day where you wake up early and then feel sleepy in the night, and then the cycle will continue. It will become a habit. Cool. 8 o'clock, 6 o'clock, 5 o'clock. Praveen, 10 o'clock. Lazy fellow. Okay. The new formula revision will come very soon. Speeds of the gas molecules. Let's talk about it. Like I said before, the speeds of the molecules range from almost very low to very high speeds. But most of the molecules, like let's say for example, one molecule has a speed of 1 meter per second, another has 0.2 meters per second, another has 500 meters per second, another one has 20 meters per second, another one has 2 meters per second, another one has 21, another one has 19, another one has 20, another one has 1000 meters per second, another one over here has 22 meters per second, another one over here has 20.2 meters per second, another one over here has 19.9 meters per second, another one over here has 21 meters per second, another one over here has 20 meters per second, another one over here has 0.3 meters per second. If you look at these molecules, do you see that there are low speeds also, high speeds also, but there is a particular speed which is very commonly found. What is that? That is your most probable speed. In this case, the most probable speed is around is around 20 meters per second. Is around 20 meters per second. Yes or no? How many of you saw that? Very good. Yes. Okay. I don't think I'll have time for completing waves, Krutik, Pranav, but you can watch my old Zero to Hero or Flash series or even the Pathfinder or Nurture series. Okay. So you can do that. So if you notice the distribution of the molecules, I can draw a graph out of it. This is your speed. This is your speed. And this is the number of molecules at that particular speed. That graph goes something like this. If this is at some temperature T, you will see when the temperature increases, that graph will go like this. Okay, it will shift. So when temperature increases, you will see the speeds will become slightly on the higher side. So that's the reason why the graph shifts. And you can see there is a peak which is achieved. There are maximum number of molecules at a particular speed. That is called as the most probable speed. That is called as your most probable speed. Is that okay, my dear students? So what are these most probable speeds? Then average speeds and then RMS speeds. Let's talk about that as well. When I say this is most probable, that is most likely speed. This is the most likely speed. Or I can also say many molecules or majority have speed around this. Majority have a speed around 20 in this case. Okay. You also have something called as the average speed. That is simply put V1 plus V2 plus Vn divided by n. Simple average. You also have RMS speed, which is V1 square RMS, root mean square. So first you do the squares, V1 square plus V2 square plus V4 square, like that till Vn square. And then you take the mean. First square, then the mean. Mean means average. And then you take the root. So root of the average of the squares, that is RMS. So what are these three speeds in case of gas molecules, ideal gas molecules? It so happens that the RMS speed is root of 3RT divided by the molecular weight. Then you have the average speed, which is root of 8RT divided by pi m. Then you also have the most probable speed, which is root of 2RT divided by m. These are three important formulas. Very, very important. RMS, average and most probable. 3RT by m, 8RT by pi m, 2RT by m. This is most probable. Then you will get other speeds on this line, on this graph, on this side. You can see the least among them is most probable. Then average is slightly more. Then RMS is slightly higher than that. So if you draw a comparison, you will see most probable is the least. Then average is in between them. Then comes your RMS. RMS is the highest, then average, then most probable. Everybody with me on this? Very good. And this graph is also called as Maxwell speed distribution graph. Maxwell speed distribution graph. Keep this in mind. All these things are important. Also, you will see that if you rearrange this equation slightly, if you rearrange this particular equation slightly and use gas law equation, you will be able to write it in this form. P into V is equal to 1/3 Nm V RMS square. This form also you can write the equation. If you rearrange it slightly and instead of temperature you use pressure, volume, number of moles. Number of moles you convert it into number of molecules upon Avogadro number and all those things. You can write it like that. Here all these things are standard. This is your pressure, of course. This is your pressure. This is of course your volume. This is of course your volume. This N is capital N, not small n. It's not moles. It's the number of molecules. Number of molecules. This is small m. So it's the mass of a molecule. Mass of a molecule. So keep that in mind. And this is of course your RMS speed, which is right over here. Right? So you can get this, or from this you can go here. Keep these things in mind. Very good. Awesome. 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 Great. Next important thing. When these molecules move and collide with the next molecule, then they change their path, then they collide with the next molecule, and then again they go along a path, then they collide, and then they go maybe somewhere here, they collide, they go like this, maybe they collide, and then they go like this, maybe they collide, and this keeps on happening. Between every successive collision, they are traveling some distance, L1, L2, L3, L4, L5, L6, etc. Sometimes they meet the next molecule very soon, sometimes they take a long time, sometimes very less time, sometimes after a long time. So their distances also could be different. So you have something called as the mean free path, mean free path, mean free path, which is the average of these distances. So it is L1 plus L2 plus Ln upon the number of distances that you have taken. But you take a large number of distance, only then it will be true. This lambda comes out to be, volume divided by root 2 pi d square into n. Very important formula, mean free path, mean free path. What are these terms? This is obviously your volume. This is nothing but, your number of molecules. Number of molecules. What is this d? This is the diameter of the molecule. This is the diameter of the molecule. This will be given to you. This will be given to you in some or the other way. This is the mean free path. Keep this in mind. Is that clear? Okay. The average distance between successive collisions. From the mean free path and the average speed, you can find the average time between the collision also. You can find the average time between the collision also. Oh my god, I need to do this. Okay, leave it. So the average time between the collision, time is distance by speed, distance is lambda, speed is basically V average. Lambda you can find from here, and the average speed you can use this formula. You can use this formula, right? So this is how you find the average time duration between the collision. Average time between the collisions. Between the collisions. Keep this in mind. Is that okay? Cool? All right. All right. So this was all regarding the speeds and the Maxwell speed distribution curve along with mean free path. I think it's a good time that we start solving some questions, and then we'll go to energy part. Okay. So 4 molecules of speed 2, 3, 4, 5. RMS is how much in kilometers per second? Just use the definition of RMS. I think you will get the answer. So root of mean of the squares. So first square the things, which is 2 square, then 3 square, then 4 square, then 5 square. Average 1, 2, 3, 4. 4 terms are there. So divided by this. So root of how much is 2 square plus 3 square plus 4 square plus 5 square? 4 plus 9 plus 16 plus 25. Come on, my dear students. Come on, my dear students. How much is it? Is it 54 by 4? So won't it be root of 54 by 2? Root 4 is 2. So I think it should be option C. How many of you wrote option C? If you wrote C, proud of all of you. Yep. No, it is not B. It is option C, Siva. Be careful. Yes, Praveen. Yes, Black Ops. Very good, Vaishnavi. Very good, Boss Gaming. AGL. Very good, Anugna. Very good. Now finally, you guys got it. Moving on to the next one. Density is given. RMS speed is given. Pressure exerted by the gas on the walls is. Pressure exerted by the gas on the walls is how much? Come on. Which formula you might need? I think RMS speed is given, right? And pressure is asked. So using RMS speed formula, which is root of 3RT by M, and combining it with gas equation, PM is equal to rho RT. So RT by M, RT divided by M, isn't it pressure by density? Isn't it pressure by density? So RT by M, I'll just put it as pressure by density. Pressure by density. That's it. So it will look like this. So this is your VRMS. But what do I want? I want the pressure. So square both sides. So VRMS square is 3P by rho. Therefore, pressure will be VRMS square into rho divided by 3. VRMS square into rho divided by 3. Everybody with me? Everybody with me? Great. So now just have to substitute the values and see what do you guys get. That's it. So the pressure will be VRMS square. So that is 500 square into density 6 into 10 to the power minus 2 whole thing divided by 3. 3 goes with 6 2 times. So 5 2s are basically, this is 5 square. So 25 into 2. So this will be basically 25 into 10 to the power 4 into 2 into 10 to the power minus 2. So yes, just check this out. Is it 5 into 10 to the power 3? 5 into 10 to the power 3. Yes, option A. 5 into 10 to the power 3, everyone. Very good, Achiever. Very good, Black Caps. Amazing, amazing. So we had to use two formulas over here. One was ideal gas equation. Second was the RMS speed formula. These kind of questions, again, very common. Mean free path is proportional or inversely proportional to which of the following? This question has come in JEE Mains before in a different way. You won't believe such direct questions also come. You would be lucky. It depends on the shift. But yeah, if it comes, you should remember the formula. That's why this chapter is very important. Come on. I just gave you the formula. Lambda is volume divided by root 2 pi d square and n. Inversely proportional to the diameter? No. Inversely proportional to the square of the diameter? Yes. Inversely proportional to the number of molecules per unit volume? Okay. Yes. Both B and C? Yep. Definitely. It is answer D, I believe. It is answer D. Because this you can write it as, I'll show it in the next step. This you can, this you can write it as 1 by root 2 pi, which is a constant, 1 by d square, and this is 1 by n by v. So you can see clearly it is inversely proportional to d square and also number of molecules per unit volume also. Both B and C are correct. Both B and C are correct. Very good, Sharon. Very good. Grishma, Black Caps, Anugna, Vaishnavi, AZWXN, IT Delhi. Yes, the Boss Gaming. Correcto. Moving on to the next question coming up on your screen. I think I showed the answer by mistake, but still try to solve this and let's see how many of you can quickly get it. Pressure is doubled when volume and mass is constant. The frequency of the collision with the walls will, the frequency of the collision with the walls or the molecules will, what do you think will happen? Think. Pressure is doubled keeping the volume and the mass constant. Pressure is doubled keeping the volume and the mass constant. Think about it. What will happen? Then use the ideal gas equation. PV is equal to nRT if you like it. Pressure is doubled. Pressure is basically doubled. Volume is not changed only. Number of moles not changed because mass hasn't changed. R though is a gas constant, so temperature is doubled. So 100% temperature is doubled. you take any speed formula, speed is always proportional to the root of the temperature. Be it most probable, be it average, be it RMS, every time it is under the root. So my dear students, if the temperature increases 2 times, basically root of temperature will increase how many times? Root 2 times. So speed will increase root 2 times. Great. Next, what will I do? Time between collisions, time is distance by speed, time is distance by speed, and frequency is 1 by time. So therefore, frequency is directly proportional to the speed, because time is inversely proportional to velocity, frequency is inversely proportional to time. So frequency is directly proportional to velocity. So if velocity has increased root 2 times, won't the frequency also increase root 2 times? Hence it increases by root 2 times. That is the answer, which is IIT Delhi. Got it? IIT Dholakpur. Yeah, I've heard a lot. I have seen one genius scientist also these days, very trending. One kid is there, he is doing some amazing things, amazing inventions. And it seems that the kid is from IIT Dholakpur. Is that true? Crazy inventions, like, inventions for how not to get wet in the rain, how to convert a petrol bike into electrical bike, how to convert electric bike into petrol bike, how to create a problem for the solution. So in IIT, what happens is you find the solution to a problem. So there are some kids who are probleming the solution, not solutioning the problem. Very interesting. You should watch it when your JEE is over. You will feel very happy because you will be entering a true IIT, not Dholakpur, right? Chota Beam. Yes, Chota Beam is the new inventor. Please don't become Chota Beam. Okay. The mean free path of the gas is 2. The RMS speed is 10. What is the time interval between the collision? Direct question. Time is distance by speed. Distance is 2 centimeters. So 2 into 10 to the power minus 2 in meters. What is the speed? Speed is basically 10. So yeah, it's 10. Correct. Perfect. What is the time interval between the successive collisions? So it will be 2 divided by 1000. 2 divided by 1000, which is 1 by basically 500th of a second. 1 by 500th of a second is option B, IIT Bombay. Option B, IIT Bombay. Very good, very good. Amazing. Shall we go ahead now to the next part? Shall we go ahead to the next part, which is coming up on your screen? And that is the energy of the gas molecules. Let's move ahead, my dear students. And you should be proud of yourselves. You should pat your back. You should be really, really happy that you are attending this class, because 3 chapters, KTG, Thermo and Thermal Expansion, will be done today. And it is not going to take a lot of time, but you will be so happy when you see questions from these chapters, and you will get at least, I'm saying, 8 marks. There is a good chance you might get up to 16 marks just from these topics alone. Okay, so let's have a look. Now, energy of the gas molecules. See, depending on whether it is a monoatomic, a diatomic or triatomic, a molecule might possess different amounts or different forms of energy. Different forms of energy. So, if a molecule, I'll just put it on the next slide. If a molecule is monoatomic, basically something like hydrogen, not hydrogen, helium, argon, something like that, then such a molecule can move in x-axis, can move in y-axis, can move in z-axis. But if it rotates, it's like a point mass is rotating. The moment of inertia of a point mass is 0. So the rotational kinetic energy will be Not there. So it is said to possess three translational degrees of freedom. It can move this, move like that, move like this, x, y, z. Translation is there, but it has 0 rotational degrees of freedom. Is that right? So I will count the total degrees of freedom, F as 3. It has totally 3 degrees of freedom. Whereas when you take a diatomic molecule, like hydrogen or oxygen, nitrogen, then such a molecule which looks like a dumbbell shape, it can move in x-axis, it can move in y-axis, it can also move in z-axis. So 100% it has 3 translational degrees of freedom. But if you talk about rotational degrees of freedom, then you will notice the molecule, if it rotates along the dumbbell's axis, it's like point masses rotating about themselves. Point masses will not have moment of inertia along that same axis. Look at it. If this is a pen, it is rotating like this. If it is rotating like this, it has negligible energy. But if it rotates like this, or if it rotates like this, then the masses are going in circles, and those have moment of inertia and also kinetic energy. So if it rotates like this or rotates like this, it has energy, but otherwise it doesn't. So it has 2 rotational degrees of freedom. So the total degrees of freedom is basically 5. That's how you count the degrees of freedom for mono and diatomic molecules. This is also particularly true even for triatomic linear. This is also true for triatomic linear molecules. Triatomic linear molecules like carbon dioxide. You will see carbon dioxide molecule, carbon is at the center, the 2 oxygen molecules are on the side, but it is linear. It is a linear molecule. So it can translate in x, y and z. It can only rotate in these 2 axes. In this axis, even if it rotates, it will not be counted as a degree of freedom because it has no rotational energy, because the point masses are on the axis of rotation having no moment of inertia. When it is non-linear polyatomic, it could be anything, any random other gas, then you will see maybe there is a molecule here, there is a molecule here, there is a molecule here, atoms here, sorry, maybe this is the bond. It can translate in x, it can translate in y, it can translate in z. It can also have rotational energies in all the 3 directions, because then the molecules, when they rotate, you will see the masses have some radius and have some moment of inertia, which contributes towards the kinetic energy. So it has 3 translational degrees of freedom. It also has 3 rotational degrees of freedom, and when you add both of them, what you get is the total degrees of freedom as 6. Total degrees of freedom, how much do you get? 6. Is that okay? Everybody with me? Cool. Now there is a formula to relate the degrees of freedom and something called as the Poisson's ratio, or the ratio of Cp by Cv. Remember, Cp by Cv, that ratio is gamma, where these are nothing but specific heat, or rather it is molar specific heat capacity at constant pressure, and this is also molar specific heat capacity at constant volume. These are 2 different things. If you remember, the value of Cp, the value of Cp minus Cv is R, because Cp is always more than Cv. Very, very important result. This result is also called as your Mayer's relation, Mayer's relationship, or Mayer's formula, Mayer's relation or Mayer's formula. This is your ratio of specific heat capacities, which is gamma, which is nothing but Cp by Cv. This gamma is also related to the degrees of freedom, and it is 1 plus 2 by F, a very, very important formula. 1 plus 2 by F is also gamma. Keep this in mind. These both are related again. So if you use this and try to find gamma for monoatomic, what do you think the gamma will be for monoatomic? Put it up in the chat box. 1 plus 2 by 3. Come on, do the math. 1 plus 2 by 3. Do the math. How much is it? 1 plus 2 by 3. Come on, guys. Won't it be 5 by 3? Won't it be 5 by 3? Similarly, do the math over here. What will be the value of gamma? 1 plus 2 by 5. Won't it be 7 by 5? Won't it be 7 by 5? So this is 5 by 3, which is approximately 1.67. Here, this is nothing but 1.4. And as you go higher, how much will it go? Gamma will be 1 plus 2 by 6, which is 1 plus 1 by 3. 1 plus 2 by 6, 2 by 6 is 1 by 3, which will make it 4 by 3, which is nothing but 1.33, right? 1.33. That's what it is. So if you notice, from 1.67, it came down to 1.4 and it came down to 1.33. So as you go from mono to dia to poly, the gamma value keeps reducing. The gamma value keeps reducing. Very good. Awesomeness. These are some important things. Now, going back over here, when you talk about energy of the molecules, there is a law of equipartition of energy, and this law of equipartition of energy states that the energy of a molecule per degree of freedom is same for all the molecules, for all the degrees of freedom. There is no bias or partiality. Oh, you're rotating more energy, or you're translating less, or you're vibrating, no, not so much, nothing like that. It is always half kT, where K is your Boltzmann constant. K is your Boltzmann constant. Boltzmann constant. K, which is R divided by Na. R divided by Na is the gas constant divided by the Avogadro number. This is your law of equipartition of energy. This is your law of equipartition of energy. Keep this in mind. From this, you can do unitary method and find the total energy of a gas. So think about this. If I take it on the other side, the energy of a molecule will be degrees of freedom into half into, instead of K, I will put it as R divided by Na into basically your temperature. Now what do I do next? This is energy of a molecule. So the energy of the gas, energy of the total gas will be energy of each molecule into the number of molecules, correct? What is the energy of each molecule? It is FRT by 2 Na into number of molecules is N. Let's play with this even more. Let's play with this, okay? Let's play around with this. What is the energy of a gas? Is it in the form of potential or kinetic energy? It's only kinetic energy. And that energy of the gas is also called as the internal energy. That energy of the gas is also called as the internal energy of the gas. which is just U, which is just the energy of the gas. So therefore, that U will be, observe this carefully now, I will write it down like this, N by Na into Fr by 2 into T. N by Na, Fr by 2 into T. What is N by Na? Number of molecules upon number of molecules in a mole. That is the number of moles, I believe. What is Fr by 2? That is specific heat capacity at constant volume, and this is basically T. So that's how you get the energy, internal energy of a gas is NCVT. And if you want to find the change in the internal energy, the change in internal energy of a gas, the change in the internal energy of a gas, then you use delta U is equal to NCV delta T, which is also commonly used in thermodynamics. Delta U is NCV delta T. CV is RF by 2. Keep this in mind. Yes? Very good. So these things you must know, my dear warriors. You must know, my dear warriors. Okay? All these things are very important. So CV is Fr by 2. Keep this in mind. I'll just probably put it on this slide. If you want to write down the formulas of CP and CV. So CV is F times R by 2. You can also write it as, R upon gamma minus 1. That's also okay. CP value on the other side is gamma times R upon gamma minus 1. These are just some additional formulas if you don't want to substitute in multiple formulas. Even if you remember these formulas, you can get these. These are some additional formulas. Usually it becomes easier to find the values. So if I do that over here, can you guys quickly tell me the value of CV and CP? What is the value of CP and CV? Come on, my dear students. CP as well as CV. The ratio should be this one only. CV will be F. F is nothing but 3. So 3R by 2. So you add R, you will get CP. Because CP is always more than CV by a value of R. So this will be 5R by 2. Even if you divide both of them, you will get 5 by 3. You can see that. Next, over here, CV value, degrees of freedom is 5. So 5R by 2. The value of CP will be plus R. So 7R by 2. You can see 7 by 5 is gamma right over here. Next, over here, the value of CV is going to be F, which is 6R by 2, which is just going to be 3R. The value of CP will be plus R. So it will be 4R. If you divide these two, you get 4 by 3. So this completes a chart, you can say. These are like condensed notes which has all the things right from your law of equipartition of energy, internal energy formulas, then your CP-CV relationships with gamma and degrees of freedom for mono, dia and polyatomic gases. Very concise, precise notes. Yes, this will be also helpful for your chemistry thermo as well, definitely. Very good. You might also get questions where you have to find the mixtures CP or CV values. The mixtures CP or CV values. So if you want to find the CV of the mixture, all you do is N1 CV1 plus N2 CV2 upon N1 plus N2. If you want to find the CP of a mixture of gases, N2 CP1, sorry, what am I doing? N1 CP1 plus N2 CP2 upon N1 plus N2. And then if you want to find gamma, please do not use this formula. This is wrong. Gamma is N1 gamma 1 plus N2 gamma 2 by N1 plus N2. If you do it, you will get a wrong answer. Do not use it. Please be careful. Instead, you find this and this separately and then divide them. CP of the mixture upon CV of the mixture. That's the only way you can find it out. Okay? Do not use this for gamma. For C you can use, not for gamma. Right. So let's start with some questions. Internal energy of an ideal gas depends on pressure, volume, temperature, size. Come on. Start answering the questions in the chat box right away right now. Yes, of course, only the temperature, nothing else. Internal energy is N CVT. You can see temperature is over here. That's all. Number of moles, CV and T, nothing else. Correct. Next one. The increase in the internal energy of the gas per unit mass per unit rise in the temperature is equal to CV, Cp are specific heat capacity at constant volume and pressure respectively. Very, very simple. Come on. The increase in the internal energy per unit mass per unit rise in the temperature is, if you write U as N, here it is CV into delta T. If you replace this N with M, this will become, instead of molar, this will just become just simple specific heat capacity into delta T. If you bring it down, so U by M delta T, what I'll again get is specific heat capacity, that's it, at constant volume. This is just specific heat capacity at constant volume. But this one is molar specific heat capacity at constant volume. At constant volume. These are two different things. When you use moles, it becomes molar specific. When you just use mass, it becomes just specific. And clearly it is saying specific heat capacity. So obviously the answer will be just CV, I believe. Yes, option D. You don't have to think much. Many people got confused in the exam because it was per unit mass. So they thought, sir, moles is given. What do I do now? Many people got confused in the actual examination. Okay. So I'm telling you right over here how these formulas are slightly different because moles is used instead of mass or mass is used instead of moles. Next one. Which of the following statement is correct for any of the processes or systems? Internal energy changes in all the processes. Internal and entropy are state functions. Change in entropy can never be zero. Actually, this is a chemistry question. I think it came over here. But still, work done in an adiabatic process is always zero. Guys, I think you can directly look at the theory and you will realize it's internal energy and entropy which are state functions. So it depends where you are, not how you reach there. So it doesn't matter whether you go like this or like this. The changes are always the same because internal energy and entropy both are state functions. Path functions versus state functions. Who are the state functions? State functions. Who are the state functions? You have entropy, you have temperature, you have pressure, you have volume, you have internal energy. Whereas when you talk about path functions, you have heat, you have work. They depend on which way you do it. So that is path functions. Is that okay, my dear warriors? Very good. Moving on to the next one. Okay, you can see a system and it is going from one pressure to another pressure via two different ways. Then the changes in the internal energy in process 1 and 2 will be which one? So basically you are going from A to B via this process or via this process. Via this process number 2 or via this process number 1. Which one do you think will have more change in the internal energy? Remember, internal energy is a state function. This was your initial state. This was your final state. The paths are different, but destinations are same and the sources are also same. So hence, because internal energy are only state functions, they are independent of the path. They are independent of the path which you take. So both must be equal. Yes, very good. C for Captain Shreyas. Very, very good. Awesomeness. Moving on to the next one coming up on your screen. Consider a process which is shown in the figure. During the process, the work done by the system continuously increases, continuously decreases, first increases, then decreases, first decreases, then increases. What do you think is the correct one? What do you think is the correct one? Come on, think carefully. Work done in this particular path. What do you think? What do you think? Come on, my dear students. Initially, by the way, work done is always the area under the graph. Work done is always the area under the graph. Earlier, only this much is the area. Then after some time, when you reach here, your area is this much. Then after some more time, when you reach here, then this much is your area. Your area is continuously increasing. So should the work. Why will it decrease and increase? No, it's just psychological. You feel that it is going down and going up. But if you see, area is continuously increasing only as you go from here to here to here. So the answer is continuously increases. It is not decrease, increase or increase, decrease. Is that okay? Yes, Avzwan. Yes, Hari Kishan. Yes, Sharon. Yes, Vaishnavi. Yes, Sivaraja. Very good, Grishma. Awesome. Thank you for all the love, Vibhasha Bhaskar. By the way, for all the, especially the South Indian students, you should talk about this channel in your school, in your coaching, or with your friends or your relatives, because this is the only JEE English channel. Many people tried starting it, but you know, many institutes or many teachers couldn't do it. And here we are at 204,000 subscribers and growing stronger day by day. So my dear warriors, my humble request, talk about this channel, grow this channel, because this is for all the students who want to learn in English and get the same quality as that you get in any other channel, right? That's the whole idea behind starting this. Cool. Let's start with the next question coming up on your screen. Who has largest internal energy? Okay. 2 moles of helium. Energy of a gas, standard formula, NCVT. NCVT formula, use that. 2 moles. So this is 2 into CV. Helium is monoatomic. So it is 3R by 2 into temperature, which is 300 Kelvin. This volume has no role to play. So don't even bother about it. This has no role only to play. 56 kg of nitrogen. Nitrogen gas N2 is 28 grams per mole. 56 is 2, but it is in kg. So it is 2 into 10 to the power 3 moles. Nitrogen is diatomic. So CV is 5R by 2 into 300. Guaranteedly this is more than this. So A option though is getting eliminated as it is. You don't even have to think about it. 8 grams of oxygen at 8 atm and 300 Kelvin. Now 8 grams, oxygen molecular weight 32. So 8 is 1/4. So oxygen is diatomic. So 5R by 2 into 300. Oh, by the way, this is definitely less than any of these things. So this also gets eliminated. This also gets eliminated. 6 into 10 to the power 6 molecules. If you see the moles of this, 6 into 10 to the power 26 by 6 into 10 to the power 23, it's 10 to the power 3 moles. It's 10 to the power 3 moles. So 10 to the power 3 into argon is 3R by 2 monoatomic into temperature is 900. So the only two contenders are this one and this one. Who is more among these two? Who is more among these two? Come on, my dear warriors. Who is more? Is this one more or that one more? I am pretty sure that one is more. Perfect. Yes. Option B is the correct answer. Got it? How we got it? The correct answer? By checking the number of moles. Yep. Great. Yes. Yes, Siva, we should take this channel to 1 million subscription. Definitely. Cool. Let's go ahead to the next concepts of thermodynamics now. We have slowly reached thermodynamics. Get ready. I know it is almost close to lunch time, but I feel that this is not going to take much of your time. we will do these parts really quick. Okay? Do you want a break or no? Do you want a break, or should we continue and finish off the remaining things in the next 40, maximum 45 minutes? Because remember, heat engine, refrigeration, Carnot cycles, they are deleted from the JEE physics syllabus. So don't have to study. Don't have to study all these things. Cool. So let's start with thermodynamics, the first law, and then you also have the zeroth law. First, let me tell you about the zeroth law also. The zeroth law of thermodynamics, which everybody must be knowing it. If A and B are in thermal equilibrium, that means their temperatures are same, and B and C are also in thermal equilibrium, then A and C, even without touching, will be in thermal equilibrium. That's all. That's the first law, which is actually the zeroth law. Why did the zeroth law came to be known as the zeroth law? Because it was discovered after the first and second law, and then they realized, arey, this is more basic and elementary than the first or the second law. So what is less than 1? 0. So if tomorrow somebody discovers even more fundamental and more basic Phaltu law, but it is important, then it will be probably called as the -1th law, or who knows, -2, and so on and so forth. Okay, let's continue. Wow, Aswin had the lunch during the class itself. Very good. Then talking about the first law, it's about this Pandu Champa story, or this Pandu story. Pandu is very hungry, just like you are. So what does Pandu eat? Pandu eats vada pav. Pandu eats vada pav, and vada pav has calories. Vada pav has calories. You eat idli, you eat dosa, you eat paddu, you eat paratha, you eat Maggi, you eat noodles, you eat kathi rolls, you eat vada pav. It's up to you. You eat pizza, you eat burger, you eat some calories. So that calories is basically heat. So after that, this particular Pandu becomes strong, definitely, and he's lifting weights. You can see that. He's lifting weights. He's doing work. He has gained some energy which is stored inside of him, and he's lifting. That means he's basically able to perform doing some work. That's all that first law is. That is all that first law is. So it says that the heat which is supplied goes into changing the internal energy and also the doing work part. That's all the first law is. Keep this in mind. In chemistry, this law looks slightly different because of the sign convention. So what's different is this. Observe. In case of physics, when you talk about work, the formula for work is integral PdV from V1 to V2, and if it is positive, that means it has expanded, and if it is negative, that means there is contraction. In chemistry, it is exactly opposite. There is a minus sign here. If it is positive, that means it has contracted, and negative means it has expanded. So it is exactly opposite, because when we define work here, it is the work done by the gas. It is the work not by the system, it is work done by the gas on the surroundings. So that's the reason why the sign convention is different. Yes, definitely. So Tarun, that's why we will be doing mock tests. Next Saturday we'll be having a mega mock test. Okay, mega mock test will involve questions from multiple chapters also. Multiple chapters. And by the way, today also, when I started my lecture, thermal physics, I hope I showed, remember I showed all the mixture questions, time pendulum, then your errors, then your mechanics, stresses. We combined all the questions, if you remember. Yeah. So we, if you have missed the starting part, please watch it, Tarun. That will help you. And obviously the mock test will be anyways doing mixed questions as well. Cool. So that is regarding work. Internal energy we have already discussed, so no point discussing it again. If I talk about heat, heat, this heat is the heat which is absorbed, again this is by, absorbed, just like by, absorbed by the gas, absorbed by the gas, and the formula for Q will depend on the process, so N, C for that particular process into delta T. It depends whether it is pressure constant, volume constant or something else. Also keep this in mind that if the value of Q is positive, that means it has absorbed, that means it has absorbed, and if it is negative, that means it has released, that means it has released. One more thing in work which you should know, if you have pressure versus volume graph, if you have pressure versus volume graph, the area under the graph, the area under the graph, this area under the pressure volume graph gives you the work done, gives you the work done. Okay, all these things are important with regards to first law. Delta U I have already told you, it is NCV delta T in the KTG part. So there is no point repeating that over here again. Okay, work done and heat. Keep all these things in mind. Now, I think we can solve some questions maybe. Yeah, here is the first question coming up on your screen. Just purely based on first law. In a given process for an ideal gas, work done is 0, heat is negative, then temperature will increase, volume will increase, pressure will remain same, temperature will increase. Straightforward question. Straightforward question. Come on. Answer, guys. Use your first law. We know dq will be du plus dw. This is a differential form. Small heat is small energy change plus small work. dq is negative. Work done is 0. So naturally, dw will also be negative. So the work is negative. This can only happen in the contraction process. In the contraction process. So that means the volume has decreased. Oh, I think the arrow mark has gone slightly up. It is B. The volume has basically decreased. Is that right? Everyone with me? Everybody with me? Right? Oh, sorry. What did I just do? I'm so sorry, guys. I'm so sorry. What did I just do? My blunder. Big blunder I did. So sorry. Again, repeat. Ignore. dq is, my bad, du plus dw. This is our first law of thermodynamics. Work done is 0. Work done is 0. dq is negative. du is then obviously going to be negative. So du is ncv dt. So if du is negative, that means dt is also negative. That means the temperature has gone down. So hence answer will be A. Yes, A is the correct answer, not B. So what I told before was for something else. Ignore. So this is the correct way of solving it. Yes, yes, yes. Is that okay, everyone with me? Awesome. Let's go to the next one coming up on your screen. The molar heat capacity of a diatomic gas, if it does this much work, when this much heat is supplied to it, is how much? What is the heat capacity in that particular process? Okay, let's use Q is equal to delta U plus work. Clearly, what and all is given. Work is done by the gas. Work is done. Molar heat, work is done by the gas, and that is basically Q by 4. So this is basically Q by 4. So therefore, delta U will be Q minus Q by 4, which is 3Q by 4. Now delta U, we all know, is N CV delta T. This is 3Q by 4. But this is a diatomic gas. CV is 5R by 2. So it will be N 5R by 2 into delta T is equal to 3Q by 4. This 2 cancels over here. This will become 2. Now what do I do next? I want to find the molar heat capacity. Q will be NC delta T. That's the formula for Q. If you remember correctly, over here, where did it go? Here. Q is NC for the process delta T. That C depends on that process. So over here, I don't know C, but I know the value of N delta T from here. I know the value of N into delta T from here. Observe carefully what will happen next. If I find the value of N times delta T, 3Q remains on the top, 5R and 2, that will become 10R. So 3Q by 10R will be the value of N delta T. So why not put this as 3Q by 10R into C, and this Q is as it is. Q cancels, so C will be 10R divided by 3. 10R divided by 3. Captain Shreyas is the answer. Very nice. First law is used to find only the value of N delta T to be substituted here to find the C in that process. C is a process specific variable. Depends on the process. Moving on. A gas is compressed from this to this. Joules of work energy is added by heating. Then internal energy is how much? Then the internal energy is increased, decreased by how much? Come on, think about it. So for that, what we will do is first use our first law, which is heat supplied is the delta U plus W. So therefore delta U will be Q minus W. Q is already given. How much energy I have applied? I have given 100 joules. I have already given. Work, I can use P delta V formula, PdV formula. So the pressure is 50. The pressure is 50. And the volume goes from 10 to 4. Final minus initial. 4 minus 10. Come on, my dear students. So this will become 100. This will become minus of minus 300, which will make it 400 joules. So increases by 400 joules is option A. Increases by 400 joules, that is option A. Cool? Everyone? How many of you have got confidence now, at least till the topics that we have studied? If you have got that confidence, very good. And if you have joined in late, please watch it from the start. These are something like zero to hero, one shots, crash, a combination of these sessions, which is what we call it as the flash series. And let me tell you, on Tuesday, I am going to take up semiconductor logic gates. How many of you want that chapter? How many of you want that chapter? Yeah? High weightage chapter. Do you want me to do it? I'll be doing it on Tuesday, 6 o'clock. Within 2.5 hours, we will complete semiconductor logic gates, all the important things. Remember, transistors is deleted from the syllabus. Many things are not there. Okay, so only the things which are there, that will not take us much of time. We'll do it on Tuesday. So be there. Let's go to cyclic and non-cyclic processes, and then other things. Everyone get ready for it. Yeah. Okay. So what do I mean by non-cyclic versus cyclic? So imagine there is some pressure versus volume or pressure versus temperature graph, and I go from one point to the other. I'm going from this initial point to this final point over here. That is a non-cyclic process. I have not returned back to the same point. But if I have a diagram like this, this is pressure, this is volume, or it could be temperature, anything. I came back to the same point. My initial point is equal to the final point. This is basically your cyclic process. When you have a non-cyclic process, which is like this, you have multiple path options. You can go via path 1 or path 2. You will see the work done in path 1 may not be equal to the work done in path 2. The heat supplied or absorbed in path 1 may not be heat supplied in path 2, but the change in the internal energy will be the same in case of non-cyclic process. But in the case of cyclic process, because you came back to the same point, your delta U will be 0. You came back to the same state. So initial and final are same. So delta U is 0. So using first law, Q will be 0 plus the work done. Therefore, the heat absorbed or supplied will be the work done. This is only true for cyclic processes. Keep this in mind. And a specific value which you need to know for cyclic process is this one. This is pressure volume. This is pressure volume. If the cycle is clockwise versus the cycle is anti-clockwise, if the cycle is clockwise, then it is positive work in that cycle, and the work is this area enclosed. This area which is enclosed is that positive work. Whereas if it is anti-clockwise, you measure that area, that will be the negative work done, negative work, or even the heat, one and the same thing. If heat is positive, work is also positive. If heat is negative, work is also, accordingly the same sign. So clockwise is positive, anti-clockwise is negative. In chemistry, it is exactly opposite. The sign conventions for work are exactly opposite, so don't get confused. In a cyclic process, delta U is 0. Yes, like I said, delta U is 0 because you are coming back, Siva, at the same point. You are coming back at the same point. So there are some interesting questions on that. Observe this and see if you are able to solve. There is a gas which undergoes cyclic process as shown. The amount of work done by the gas is how much? In JEE sometimes deliberately, I don't know why they do it, they are very cunning, smart, they use the word the work done on the gas in physics paper. And every student will mark some answer, but the answer will be exactly opposite in sign. So pay attention to those words in the actual exam because those things have happened in the previous year's papers. You can check it out. So pay attention to the words. Don't think always it will be by the gas. Sometimes even in physics paper, they might tell you on the gas. Just chumma to make your marks go negative. Okay. So what do we need to do? We just need to find the area, right? How much is this? This is basically 2V0. How much is this? This is basically P0. So how much is the area? It is 2V0 into P0 and it is anti-clockwise. So the work done will be negative 2P0 V0. This negative is because it is anti-clockwise. Just check that out. Yes, IIT Bombay is the correct answer. Very good, Hari Krishna. No, it is not C. Yes, Sivareja, it is B. Boss Gaming, it is not C, bacha. You have to pay attention to the direction. It is anti-clockwise. If it was a chemistry question, it would be positive, but then it would be mentioned work done on the gas. Okay, cool. Next question. In this system, the heat rejected during this cycle. Observe carefully. It is anti-clockwise. If it is anti-clockwise, the work, which is also the heat, will be negative. That means the heat is rejected or basically released. The heat is basically rejected or basically it is released. Very good. Now count the area. Measure this area. That's it. That will be the work done. This is 2V. This is P. So again it is 2PV is the area. So hence the heat rejected is 2PV, which is option B again. Is that right? Yes. Very good. So the area is 2PV, but the heat value will be minus 2PV. But the question is how much heat is lost or rejected. The answer will be 2PV. Don't say, sir, where is minus 2PV in the answer? It's like I had 100 rupees, I lost 20 rupees. So my amount reduced or my amount changed by minus 20, but the amount I lost is 20. So I have lost this much joules, but that sign need not be shown there because already the question mentions the word lost. Heat energy absorbed by the system going through this cyclic process is a very interesting question. This is a circle. Again, all you need to do is find the area, and the area of the circle we know is pi r square. So what might be the radius? What might be the radius? I think you can clearly see the radius is basically 10 because the diameter is 20. Diameter is 20, radius is 10. So hence the area will be pi into 10 square, which is 10 square pi joules. But be careful, the question says the heat energy absorbed, and here this graph is shown like this. Is it positive or is it negative? Is it positive or is it negative? Let's see how many of you tell me the correct one. Yeah, if I lost minus 20, then I would have gained 120 rupees. Correct. So if I say if I lost plus 20, that means actually my amount has become 80. So my dear students, although you might see it is anti-clockwise, still I will say it is positive. You know why? This is volume versus pressure. How many of you saw that before I told you? It's not pressure volume, it's volume versus pressure. So the convention will become again opposite. So clockwise will become negative, anti-clockwise will become negative. So strictly speaking, this is positive work or heat. Positive work or heat. So 100% the heat has been absorbed because it is positive. It's positive, yes. So answer is 10 square pi joules. So some of you saw that. Sivas, no, who is it? AZWXN saw it. Very good, very good. Yes, black caps. You need to be very careful. And you know the funny part will be, if there were two options with 10 square pi, one is positive, one is negative, 100% many people will look at the anti-clockwise sign and they will mark negative. They will get also negative marks. So see what is there in the y, see what is there in the x. I hope listening to all these classes, you are realizing that your JEE exam is not about completing the syllabus. Even if you complete the syllabus, you might get 60 percentile. But a student who completes 60% can get 90 plus, 95 plus percentile. Understand? It's all about how you attempt the paper. Actually speaking, with 60% syllabus, you can get close to 99, 98 percentile. In fact, I'll be uploading a video on that today evening. You can watch that. For a cyclic process, work done by the system is 0, equal to the heat, more than the heat, independent of the heat given. This is straightforward. This is straightforward. Come on, my dear students. In a cyclic process, the work done by the system is 0, equal, come on, independent of the heat given to the system, more than the heat, equal to the heat. This is very straightforward, equal to the heat, because in a cyclic process, what happens? Delta U is 0, so Q is equal to 0 plus W, so Q is equal to W. Just some time back I told you this, so it is equal to the work done, as simple as that. Okay, shall we go to the last part of this chapter now? Awesome. Let's go to the last part of this chapter. Everybody ready? Everybody ready? Okay, come on, let's go to the last part of the chapter. So what is the last part of the chapter? The thermodynamic processes. Mainly there are some 4 or 5 processes which we need to know. What is the work done? What is the internal energy change? What is the heat? What are the other characteristics and all that? Okay, so let's have a look at it. Starting off with the most simplest of all, and that is isobaric process. Isobaric process. So in isobaric process, it's the pressure which is constant, and because PV is nRT, you will see volume is directly proportional to the temperature. Also in this process, if you draw the graph of pressure versus volume, it will be a very easy peasy graph because pressure is constant. it will just be like this. But if you draw another interesting graph of volume versus temperature, because volume is directly proportional to the temperature, you will find the graph to be like this. You will find the graph to be a straight line. Next important thing is what is the heat, what is the delta U and all those things. Delta U for any process is always NCV delta T. That is the standard formula. CV will come always. The heat, because this is constant pressure, will have N C for the process, which is Cp, into delta T. And the work, well, the work will be simply P into delta V, nothing more. P into delta V, that's all, which you can also write it as NR delta T, one and the same thing. One and the same thing. So these become the most important formulas for isobaric process. Till this point, if it is clear, give me a thumbs up. Till this point, if it is all clear, give me a thumbs up. Yeah, cool. Chalo. Let's go to the next then. Next is isocoric. Next is isocoric process. For isocoric process, obviously volume is a constant, and because PV is nRT, volume is constant, the pressure is directly proportional to the temperature. Pressure is directly proportional to the temperature. So on a PV diagram, the graph is just like this, but on a pressure versus temperature diagram, you can see it is directly proportional. So it is a straight line over here. This was pressure temperature, earlier it was volume temperature. It depends from process to process. You can't remember, but you should just go with gas law equation, that's all. Okay. Now, talking about all the other parameters. Here, the interesting thing will be the work done will be 0 because volume only did not change. There is no area under the PV graph. It's a vertical line. There is no area under it. So no area, no work done. Delta U will be NCV delta T, and so will be Q, which is NC for the process and delta T. Both of them will be the same because Q is delta U plus work done. Okay, this is for isocoric process. Give me a thumbs up if this is okay, this is understood. Give me a thumbs up. Everyone, till this point? Yes, very good, very good. Let's move on. Next concept. Next concept. What is it? It is isothermal. Isothermal. So in isothermal, obviously the temperature will remain a constant and the pressure will be inversely proportional to the volume because PV will be a constant. So in such cases, when you show the PV diagram, the graph will look like this. You can draw more such graphs. Here the temperature is low. As the temperature rises, the graph shifts up and up and up over there. In this case, if you talk about change in the internal energy, guess how much will it be? NCV delta T, temperature did not change, delta T will be 0. So delta U, that's it, vanishes. It becomes 0. Perfect. And the work done will be nRT ln V2 by V1. In chemistry, it was V1 by V2. If you want, you can also write nRT as P1 V1 ln V2 by V1. You can also write, instead of P1 V1, you can also write P2 V2 also. You can also write this as nRT log, instead of V2 by V1, you can also put P1 by P2. All of them are the same thing. All of them are the same thing. And by first law, the heat will be the work done because delta U is 0. So keep this in mind. Q will be equal to the work done because delta U is 0. No change in the energy, so that's why no change in the temperature. Cool? This is for isothermal process. Isothermal process. Is it done and dusted? Isothermal process. All the slides hand printed will be given to you in the PDF. Where is the PDF available? On the Telegram channel. Make sure you check that out. Make sure you check that out. Okay? Cool. Moving on to the next one coming up on your screen, and that is adiabatic, 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 adiabatic. So in adiabatic, the heat supplied is basically 0. So I'll just put it later on over here. In fact, I can say PV raised to gamma is a constant. You can also say TV raised to gamma minus 1 is a constant. That is the law that you will be using. And the heat supplied is 0. In this case, delta U is still NCV delta T. Of course, no change. So what about the work? What about the work? Use your first law. Use your first law. You will see it is minus delta U. So if you want, you can write it as minus NCV delta T. And if you want, you can also write it like this, because CV is R upon gamma minus 1, okay, into delta T. And NR delta T, okay, this minus sign, you can take it inside. So 1 minus gamma. NR delta T is nothing but P2V2 minus P1V1. So that's what it is. P2V2 minus P1V1 upon 1 minus gamma. So that is also your work done. Either you do this or you do this, you will get one and the same thing. That is for your adiabatic process. And if you look at the graph, of pressure versus volume, the graph will be again a curved line. The graph will be just a curved line, right? Yes. Cool. No, when heat is not supplied, temperature may not remain constant because it might use the internal energy to expand, or it might compress without taking it from the surrounding, and because of which the temperature might change. So internal energy might change in the work done. Internal energy might go into the work done. That's why you will see temperature may change in the adiabatic process. Is that okay? Cool. Next is the godfather of all the processes. Godfather of all the processes in general, it is called polytropic process. Polytropic process. In a polytropic process, PV raised to alpha is a constant. Alpha is some number, it's not gamma, it could be gamma, but it is some rational number, that's all. Any process in this form is a polytropic process. Like, for example, PV square is 4, P by V is 7. This will just become PV raised to minus 1 is equal to 7. Or P root V is equal to 3.4. So this is P into, therefore it is P into V raised to half is equal to 3.4. This is also a polytropic process. But this one, PV plus 1 by V minus 3 is equal to 7. This is not a polytropic process. Or ln P V, the whole thing plus V square by P into 4. This is equal to 7. This is also not a polytropic process. It should be in this form. P into V raised to something. P into V raised to something. Can you write JEE Mains? Definitely you can write, Deepa. Who said that you cannot write? But the question is about marks. So you might aim for 90 percentile by doing 5-6 topics. And I'll be giving those 5-6 topics today evening. Everybody wants that. 4 o'clock that video will come, I think. So watch that lecture. Watch that class. Okay. So in case of a polytropic process, also delta U is still NCV delta T. There is no change in that. The work done formula is very similar to adiabatic process formula. Instead of gamma, you have alpha. Instead of gamma, you have alpha. That's all. Instead of gamma, you have alpha. So it is just P2V2 minus P1V1 upon 1 minus alpha. And from this, you can find Q, which is W plus delta U if you want to. Okay, so you can find Q by adding both of them. As simple as that. Now, interesting thing about the polytropic process is that if you draw pressure versus volume graph and the graph is like this and you draw a tangent, you draw basically a tangent. Then the slope of pressure versus volume graph is minus alpha times P by V. A very, very important formula. The slope of pressure versus volume graph is minus alpha times P by V. Becomes very useful for finding the slope of any other graph. I will tell you how in a bit. But for now, observe this. When you have PV raised to alpha is a constant, if I tell you the different values of alpha, can you guess which process it is actually representing? Can you guess which process it is actually representing? Let's say alpha is 1. Let's say alpha is 1. That means PV is a constant. When does this happen? When does pressure into volume become constant? This is when it is isothermal process. This is when it is an isothermal process, yes or no? When alpha value is 0, that means PV raised to 0 is a constant. That means pressure is a constant. And when does this happen? This happens for isobaric process. You can prove it otherwise, that if alpha is infinity, so PV raised to infinity is constant, you take the infiniteth root. So P1 by infinity into V raised to 1 is constant 1 by infinity. P1 by infinity is P raised to 0. This is another new constant. P raised to 0 is 1. So volume will be a constant. So when it is infinity, it becomes a isocoric process. Isocoric process. And when it is gamma, then it becomes adiabatic process. It becomes adiabatic process. So you can see by changing alpha in this God formula, you can go from any process to any process. If I put alpha as 1, it is isothermal. The slope will be minus P by V. If I put it as adiabatic, it will be minus gamma P by V. So the slope also will change depending on which kind of process it is. Yep. Is that right? So this is a very, very important generic idea about all the processes on one slide, and all the other details, be it polytropic, be it adiabatic, isothermal, isocoric, isobaric. All these details and the graphs I have shown it to you over here. I think it's a good time we start solving some questions now. Here is the first question. Starting from the same condition, gas expands from V1 to V2 in 3 different ways. The work done is W1 if it is isothermal, isobaric and adiabatic. Okay, let's try to think. This is pressure, this is volume. I go from same volume to the next volume. From this volume, let's say over here, to another volume. Okay, and I expand. So from V1 to V2. So W1 is isothermal, W2 is isobaric. So if you are isobaric, you will go like this. This is process number 2. If you are isothermal, then you will go like this. If you are isothermal, then you will go like this. If you are adiabatic, well, now observe carefully in that previous formula which I gave you. In adiabatic, alpha is gamma. In isothermal, alpha is 1. So from this, can you tell me whose slope is more than whose slope? Whose slope, is it for adiabatic or is it for isothermal that the slope will be more? And who is how many times of whom? For isothermal, the slope of isothermal will be minus 1 times P by V. The slope of adiabatic will be minus gamma P by V. Minus P by V is there. So taking just gamma over here, won't this be the slope of isothermal? So can I not say the slope of adiabatic is gamma times the slope of isothermal? So whose slope is more? Adiabatic. Whose slope is less? Isothermal. Why? Because gamma is always more than 1. Gamma is always more than 1. So if 1 is isothermal, I should show higher slope for adiabatic. For adiabatic, it will be like this. So this will be 3. This will be 3. Now see who has more area, who has less area. Obviously, when we talk about work, it is basically the area. I think 3 has the least area, like you can see. 2 has the most area, 1 is medium. So that's it, 2, 1 and 3. 2, 1. 2 has the biggest area, then 1 and then 3. That's all. That's the answer. 2, 1, 3. Is that right? How many of you wrote A? Yes. Very good. Yes. Yes, Arvindan. Yes, Vaishnavi. That's the correct answer. Next question on your screen. Whose curve's slope is more than whom? I think we just did this. We just did this now. Slope of adiabatic is gamma times slope of isothermal. Slope of adiabatic is gamma times slope of isothermal. We just did that right now. So adiabatic is steeper, isothermal is not so steeper. We just did this. Next one. Which one represents which gas? A and B are both adiabatic curves. Okay. So then the slope will be magnitude wise gamma times P by V. So you just need to check about gamma. If you talk about monoatomic gas, gamma is 5 by 3, which is 1.67, right? And if you talk about diatomic gas, gamma is 1.4, which is 7 by 5. So here gamma is more, here gamma is less. That means the slope is higher here, the slope is lower here. Because if you notice, that's what the difference is in all the options. Both mono, both dia, one mono, one dia, one dia, one mono. So slope is higher. For whom is the slope higher? I think it is higher for this guy, B. This is steeper. So that means it must be a monoatomic gas. It must be a monoatomic gas. Naturally, this will be diatomic because it is having less slope. Less slope. This is more slope, this is less magnitude of slope. So hence answer must be B, I believe. Yes, it is B. Helium and H2. Helium and H2. Helium is monoatomic, H2 is diatomic. No, it is not D. It is not D. Be careful. Many students make a mistake in this question. It is IIT Bombay. B is the answer. Check it again carefully. For mono, it is 1.67. Slope is higher. Slope is higher for B. So B is monoatomic. Mono is helium. Mono is helium. Many students, in fact, write a wrong answer for this. Be careful. Okay? Cool. Let's go to the next one. In a given system, in which work done by the system equals a decrease in the internal energy, the system must be which type of process? Okay. Work done equals the delta U. Okay. But we know Q is work plus delta U. So therefore it is minus delta U plus delta U. That means minus minus cancels, becomes 0. Oh, this only happens in adiabatic process. So adiabatic process must be the answer. Option B. Yep, correct. Yep, B. Very good. Awesome. Moving on, next question coming up on your screen. Temperature of a gas increases √2 times when compressed adiabatically to half the volume. The equation is temperature is given and volume. Is there some formula which relates temperature and volume? Yes, there is. And that is TV raised to gamma minus 1 is a constant for adiabatic process. So, initial temperature T, initial volume V, which kind of gas is this? Not even given. Okay. Is equal to final temperature √2 times. So, √2 times of T into volume becomes half the volume. So V by 2 raised to gamma minus 1. T cancels. V raised to gamma minus 1, V raised to gamma minus 1 cancels. So 1 will be root 2 times this 1 by 2 raised to gamma minus 1. Okay, I will bring this guy on the top and I will see what do I get. So 1 will be 2 raised to half into, this will become 2 raised to 1 minus gamma. So therefore, this will become 2 raised to half plus 1, which is 3 by 2 minus gamma. 2 raised to what is 1? 2 raised to what number is 1? Obviously 0. So 3 by 2 minus gamma must be 0. So gamma is basically 3 by 2. If gamma is 3 by 2, we know that PV raised to gamma will be a constant. So therefore, PV raised to 3 by 2 will be a constant. So PV raised to 3 by 2 is option A, I believe. Yeah, that's the correct one. Very good, Hari Krishnan. Siva, very nice, very nice, very nice. Proud of all of you if you got the correct answer. Great. Next one. Two samples A and B of a gas initially at the same pressure and temperature are compressed from V to V by 2. One is isothermal, one is adiabatic. Compression, not expansion. Final pressure of A is, okay, let's draw a graph. This is your pressure, this is your volume. So this was your initial volume and you compress it. That means this is your final volume. So now if you go, let's say, what is it? One is isothermal, one is adiabatic. So you start from here, you go like this. Let's say this is isothermal. Let's say this is isothermal. This is isothermal. Is isothermal. Adiabatic must be more steep, right? Adiabatic must be more steep, right? So if I have to show more steep, that means I have to go like this. So this will be B for adiabatic process. So who has more pressure? Obviously B has more pressure than A, hence that must be the answer. So A's pressure is less than that of B. A's pressure, like you can see, is definitely less than that of B. Can you see that, my dear students? Can you see that, my dear students? Yes, definitely it is. What a tricky question, completely based out of slopes. No, it is not going to be equal. Be careful. It is going to be unequal. And we have reached the end of the class. And because we have reached the end of the class, let me also show you as you are watching this particular video. Just go down below and see this free test series. There is a link. This will expire within some time. Please click this and make sure you are enrolled in this free mock test. Look at this, 0 rupees, which was costing 1,500. So go buy it for free by just entering your login mobile number. That's all. That's the only job you have to do. And there is also a quiz which is attached like a DPP. Click on this. Again, if you are already registered, very good. Not registered, please do that right now. You will be able to attempt that particular quiz. And also the Telegram channel where you will be getting today's entire PDF. Okay. And what is the one last thing that you need to do? So many things. Shreyas Sir tells, sir, do this also, sir, join this also, give this. All this is for your benefit only, not for my benefit. What will I get giving the test? I will not get anything. My job is to teach. My job is to make the test. My job is to make these tests available for you. My job is to come here. Even if I get tired, even if I feel sleepy, even if I feel hungry, my job is to teach you. And that's why I come here. So make sure KTG Thermo done is written in the comments. Make sure you share this video. Make sure you talk about this channel. Why do I keep saying this? Because if I see more people, I'll feel more happy. I will get more excited to conduct more such classes. Or else I'll be like, okay, my students don't want to study. They don't want to enter IIT. They want to chill pill in life. So make sure you like, comment, subscribe and share. Thank you so much. This is Captain Shreyas signing off. Hasta la vista. See you and all the best and Happy New Year in advance. I have a special message which is going to come up tomorrow as well. Bye bye. Take care.